Now, very often, that's supposed to be a 2 and it looks like a 5, so I'm going to fix that. NH2. Very often, the way we write the formula gives you some clues about how things are attached together. Okay. So one thing you can look at and you can say, oh, this is probably like a little group and this is probably like another little group. Yeah. And the other thing to remember is that hydrogens have to be on the ends. Yes? Tell your partner. Oh, and everyone go touch your phone and put it in the cell hotel. Right now. Phone, cell hotel. Go. Quick, quick. And once you're back at your seats, you are going to tell your partner what is the first step in the 8-step method. Step number 1 is, what are we counting? Valence electrons. Okay, so we have carbon. How many does carbon have? 4. We have hydrogen, so that's going to be 3 times 1, right? Because we have 3 of them. How many does nitrogen have? 5. And again, we have hydrogen, so that's going to be 2 times 1. So that is 4 plus 3 is 7 plus 5 is 12 plus 2 is 14 valence electrons. And if you should be so unlucky as to draw everything in the structure incorrect, but you have written down that you have 14 valence electrons, you will get 0.5 marks. Yeah? So you can like bomb the entire question and still get 0.5. Yeah? So it's kind of nice because it means you did step 1 correctly. Now, step 2 is to draw the skeleton structure. So here we don't just have a single atom with H's, we have 2 atoms with H's. So who are the 2 atoms that are going to be in the middle? C and N. So we're going to have C and we're going to have N. Yeah, they have to be in the middle, right? Hydrogen cannot be in the middle. So these guys have to be attached to each other. So step 2 is the skeleton structure. What's going to go around C? Hydrogens. How many hydrogens? 3, because it's got a 3 beside it. So we go 1, 2, 3, hydrogen, hydrogen, hydrogen. And then we look at N, and what has to be attached to it? Hydrogens. So we have 1 hydrogen and 2 hydrogens. All right. So that's our skeleton structure. What is step 3? Add lone pairs until all have 8 electrons. Who are the exceptions? Except hydrogen, beryllium, B, and Al. Hydrogen needs 2, beryllium needs 4, boron needs 6, and aluminum needs 6. Too bad it's not 2, 4, 6, 8, but then that would not be less than 8. So there we go. Okay, who needs extra electrons here? Nitrogen, because nitrogen has 2, 4, 6, and we need to put in a pair to make 8. Step number 4. We're going to count electrons in the structure. So let's do that. Why don't you count the electrons in the structure and you can compare what to what I get. I get 14. And we don't just count them, we compare to what? The original number. Okay, so we're going to say, is this the same as the original number? I have 14 here and I have 14 here. Are we good? Yes, we're good. And if we compare and they are the same, then we are done. Okay? So that's it. There's your Lewis structure for CH3NH2. Is good? Okay. Now, this is not just about multiple central atoms, it is also about multiple bonds. Okay, so this is our next one is going to take a look at that. So we have, our next example is CH2O. Everyone, what's step 1? Valence electrons. Count up the valence electrons. Tell me how many you get. We all get 12? Okay. Step number 2. What's step 2? Skeleton structure. Try drawing a skeleton structure and then you can compare with mine. Okay, I put carbon in the middle because whenever you have a choice, who do you put in the middle? Carbon. I made it as symmetrical as possible, although really it doesn't matter whether I put the hydrogen on the top or the oxygen on the side. I could have done C, H, H, O, but it's more usual to draw a symmetrical structure. In reality, this structure would be 3-dimensional. Okay, so it wouldn't actually look like this. All right, step 3. What is step 3? Add lone pairs. Who needs lone pairs here? Oxygen needs 1 on the left, 1 on the top, and 1 on the right. Carbon needs 1 on the bottom. Okay. Step number 4. Count electrons in the structure. So you count them, see what you get. What'd you get? 14 electrons. Okay, we got 2, 4, 6, 8, 10, 12, 14. All right. Are those the same? No. So on your white sheet, okay, so get your periodic table with your white sheet. If you don't have one, let me know. I can get you a spare. Anyone need one? We're good? What does it say for rule number 5? Do you know what? Oh, that's okay. Just follow the examples along with us, and then we'll get you a book when you're doing more stuff. Anyone else need one? Here we go. Over there. Okay. So flip to the page that's beside this one. This is easy to see from far away. Okay, and then you're going to go to how to draw Lewis structures, 8-step method. Okay. We are now on step 4, and we have too many electrons, yes? How many electrons too many do we have? 2. We have 2, so we have 1 pair too many. What step do we go to if we have too many? We go to step 5, okay? Step 5, you are going to A, erase pairs from the central atom. In this case, you are going to erase how many pairs? 1 pair, okay? So in this case, 1 pair. All right, so I'm going to redraw it so you can see what it looks like, but you can just erase. Okay, I'm going to redraw it. Okay, so that's what it looks like with that pair erased. And then 5B is however many pairs you erased, you're going to turn the same number of pairs. So you're going to turn 1 pair, turn 1 lone pair. So again, we're looking at 1 pair into a bonding pair. So what that means is we are going to take a lone pair on the oxygen, and we're going to say, I'm going to be super kind and I'm going to not just keep that to myself. Oxygen says I'm going to share that with carbon. So now we have oxygen. We still have 2 lone pairs. You can put them wherever you want, but I'm going to put them just symmetrically, okay? But now that red pair is forming a second bond in a double bond, okay? And we still have hydrogen and we still have hydrogen. Okay? And at this point, you say, is it an ion? If it is, you need brackets and charge, but it's not, so we don't. Are there resonance structures? We haven't learned about that yet. So we're going to ignore step 6, 7, but we are going to go and do step 8, because step 8 is to check that all atoms have 8 electrons. Does everyone who needs 8 electrons have 8 electrons? How many electrons does carbon have? Carbon has 2, 4, a pair makes 6, and a pair makes 8. How many does oxygen have? It has lone pair, that's 2, 4, and a bond makes 6, and a bond makes 8. Okay, so step 8, you're always going to get to step 8. Check for complete octets. What's a complete octet? It just means that everyone has 8 electrons. Except who?
Except for hydrogen, aluminum, boron, and aluminum.
And I'm going to keep harping on this because it'll be easy to forget that, right? So if you say to yourself, except hydrogen, beryllium, boron, and aluminum, if you say that every time, then you'll just remember it, okay? So that's correct, and we could also double check the total number of electrons. We have 2, 4, 6, 8, 10, 12 electrons. That is the same as our original number of electrons, so we have a perfect structure now. Is good? Okay. Let us try another one. Try C2H2. Why don't you just grab yourself a piece of paper? I mean, we're on page 107, but why don't you try it on your own without turning to page 107? Okay, C2H2. There's blank paper at the back if you need some. Yeah.
So if it's a metal, hydrogen on top, inside, bottom, top. Yeah, that's fine.
And if you've forgotten the steps, feel free to look at your list of steps.
And then this is now there's 24.
And now, don't forget to elect on the list.
Well, why did you get
What you're going to do is when you get to step 3, you're going to add in lone pairs so that everybody has 8. So here you can see I don't have 8 electrons. So I'm going to add these in until I have 8. Okay? Pardon me? I'm not understanding. Sorry, I'm going to come closer so I can hear you better. Well, it does, but we're going to fix that. Okay, step 3, we add them in, and then in step 4, step 5, we're going to fix it. Okay? So in step 3, you may have noticed that we have created a problem. What problem did we create in step 3? I got too many electrons now, right? Because if I count my electrons in the structure that I drew, right, in my skeleton structure, I added lone pairs until everybody had 8. But I've created the problem that I have 2, 4, 6, 8, 10, 12, 14 electrons in the structure. That is 2 pairs too many. Okay? And that's where we come to step 5. Erase. How many lone pairs from the central atom? Okay, because we have 2 pairs too many, we're going to erase 2 lone pairs. Okay, so I'm going to take my structure and I'm going to redraw it. You don't have to redraw it, you can just erase. Pardon me? It is a foolproof method. It really helps. There is another way of doing it where you just get to use up the electrons that you have, but then people sometimes mess up on how many double bonds you end up with and stuff, so I like this one better. So we have now erased the 2 lone pairs. You can see now they're gone. Yeah? Now, the nice thing about this is it tells you if you have erased 2 lone pairs, if you had 2 pairs too many, that means you are going to have 2 multiple bonds. That can either be a double bond and a double bond, or it can be a triple bond, okay? If you erase 2 pairs, that means you're going to end up with 2 multiple bonds. If you were in a PChem, I would tell you you end up with 2 pi bonds, but that will mean nothing to you, so I won't tell you that. All right, step 6. Oh no, that was A, and then part B, we have to turn 2 lone pairs into 2 bonds. So we're going to take the lone pairs that we have left, right here, and we're going to move this into the middle, and we're going to take this one here, and we're going to move it into the middle, and so we're now going to have H, C, and now we have a double bond and a triple bond. Do you see how now we have 2 multiple type bonds, a double and a triple? So now we have a triple bond, and there we go. And now we can do our ultimate check. We can say, does everybody have 8 electrons? We have 2, 4, 6, 8. and the other carbon has 2, 4, 6, 8. This structure has a total of 2, 4, 6, 8, 10 electrons. That's how many we had at the start. So we are done. Yes? Okay. Do you remember a few days ago when I had you doing carbon monoxide and you were like, wow, this one is awful and icky and frustrating? You guys remember that?
Yeah.
Let's try carbon monoxide using this method. CO. Step number 1, valence electrons. Step number 2, skeleton structure. How many? Too many is the question. No. What happens is there's too many electrons crammed into one area. If you have 4 pairs in between 2 atoms and they repel each other and it's very unstable, you might be able to get it temporarily, but it would just come apart. Yeah. That's to do with nuclear bonds rather than like strong nuclear forces rather than electrostatic attractions. Yeah. 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 So at step 3, your structure should look like this. Hey, let's see if they're here today. Mahan is not here. Dylan is here. Thank you.
CO2 or just CO? Huh? The CO2 or just CO?
This is just CO.
Oh, that's the CO2. My bad.
Okay. Yeah. Oh, no. You're not going to worry about that. Just get rid of that. Don't worry about that. You're just going to say, this is what I have. Okay. Next step. Okay, so that's step 3. Step 4, we count the electrons in the structure. Okay, so we go through and we say, I have 2, 4, 6, 8, 10, 12. And then once you have counted the electrons in the structure, you compare to step 1. And you say, are these the same? Are they the same? Yes. Huh? Oh, it's 14. I'm so sorry. Thank you. There's 14 electrons. I can't count. Oh, I forgot the double bond. I forgot the bond. That's what I did. Look at that. Wow. Okay, it's 14 electrons. So we have 14 electrons. We compare it to step 1. And what you're going to do is you're going to say, do we have too few or too many electrons? We have too many electrons. You're going to say, how many pairs? Too many. Tell your partner, how many pairs too many? Ayush, how many pairs too many? 2 pairs too many. Okay? And what that means is in step 5, you're going to erase 2 pairs. Okay? So step 5, we're going to erase 2 pairs. two lone pairs. And although it doesn't matter where you erase them from, I tend to be symmetrical, okay? So I will probably erase them from the carbon and from the oxygen. Okay, so now we've erased two lone pairs. That's step A. We erase them. And then if we had two lone pairs, we need to turn two lone pairs into bonding pairs. Turn a different two lone pairs into bonds. So different lone pairs this time. We erased the ones on the top. And now we're going to take this one here, turn it into a bond. And we're going to take this one here and turn it into a bond. So now I still have the two on the end. I still have a bond. But the red lone pairs have now become a bond and a bond. And then oxygen has a lone pair on the right. Is good? Do you want to try SO2, which caused so many problems when you tried to do it like by cramming things together? Yeah, why don't we try SO2? Okay. Is that too big? I'm getting a smaller one. Okay. Yes. Yeah. Yes, you've erased one lone pair, and then you're going to turn one lone pair into a bond. No, no, okay, this we're going to do together. Yeah, okay, we always want to do that. Now what we're going to do is because we erased it from here, we are going to learn, oh, and actually we always erase them from the central pattern. Right? And that's going to fix your problem. Now we've got, is you've got, here we go, right on.
This one.
Between the O and S. I was gonna say, I was generous and share with you, sulfur. Yeah.
This one.
Yes,
Where do you want?
just everything right in there, perfect, yeah. Good. Oh, that's for ion bomb.
Right.
Yeah.
I see one more too.
Okay, how many valence electrons do we have? Sulfur has 6. Oxygen, we have 2 times 6. So hopefully you all got 18 valence electrons. Who should go in the middle of the skeleton structure? Sulfur. Whoever's further to the left, whoever's the singleton, should go in the middle. So there's our S, O, O. The next step is to put lone pairs everywhere, okay? So just make sure that they all have something on the top, they all have something on each side, and they all have something on the bottom. Now we count the electrons in that structure. I'll try to do a better job this time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is one pair too many. So we erase one pair, and we don't just erase one pair from anywhere, we erase it from the central atom. Okay, so here's our central atom. All right. And that means we need to turn one lone pair into a bond to help sulfur get 8 electrons. Because we said, sulfur, you have 8. Oh, now you don't have 8. Oxygen says, I have electrons that I can help you out with here, sulfur. Okay, I'm going to help you out, sulfur. I'm going to let you have those electrons as well. So if I redraw this now, I've got electrons here and here. I still have my single bond, but now I have a double bond. Okay. And then we still have this guy over here. Oopsie. That looks like this. Okay. And now we can count up all our electrons, see if we now have 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's good. So we have the correct number of electrons. And how many does oxygen have? If we look at just oxygen, it has 2 lone pairs and 2 bonds. So it's good. If we look at sulfur, it has 3 bonds and a lone pair. So that's good. And oxygen has 3 lone pairs and a bond. So that is good. All right.
It doesn't matter it doesn't matter if one is bonded to sulfur and the other.
No, because what's going to happen actually, and we're not going to learn about this today, although I'll mention it to you because you sound curious, is that actually what ends up happening with this structure is that the electrons don't just stay put. What will happen is that these electrons will actually move in here sometimes, which would give that sulfur 10 electrons, which is no good. So this pair will move out here, and you'll end up with O. And now that bond has moved out here, that one. Yeah?
So it's kind of unstable.
Well, not really. No, it's actually more stable if they can move.
What?
Okay, but just hang on, because there's more to the story than this. Okay, so now I've got 2 lone pairs here. So basically it can move back and forth and back and forth and back and forth. Okay? Charge likes to be spread out as much as possible. Yes? So if we can spread out those electrons as much as possible, that's a good thing. It turns out that the true structure is not actually double bond, single bond, flipping back and forth. What it really is, and the reason that I'm not going to show you this just yet is because you cannot draw lone pairs when you do this, but really what you have is you have a 1.5 bond and a 1.5 bond. Yeah? And the reason that we know that is because a double bond is shorter and stronger than a single bond. But it turns out that the 2 bonds are equal in length and strength. So they have to be, those electrons have to be, in this bond, have to be spread out over 2 areas. Okay? But this is not part of today's stuff, so forget I said anything. Forget you saw that, and what you have for homework now is page 113, numbers 1 through 8. Okay? Don't worry, it says give the molecular geometry and hybridization. Ignore that part. That's because I forgot to edit it out when I took this and put it in for you guys. Okay? Ignore geometry and hybridization.
That's evil. I would say I can't do it. You're gonna just say I can't do it. I'm just like hit the library and I saw a plan. He's gonna be I was like, oh, that would be sad. If I have to walk in, I have to walk in. You think I'm too much. I know a long way. Like, you're right now. Physics. Very substantial. Yeah. Yes. Yes. Oh, I'm here. I thought you were like chemistry's bad. I want to go home. I'm like, no, chemistry's not bad. I can't handle it anymore. I can't take it anymore. Yes. Oh, when you're on there, they're not there. When they're all like, okay, got it. Okay. Yes. And all of like the answers is how the own stuff. Like, no. 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 You were right there. You guys did perfect. Yes.
You ever see him again? Oops, sorry. Listen.
Yes.
After this, do you ever cancel it again?
I teach control.
Oh, you think I would do well at it?
Pardon me?
You think I would do well at it?
I'm not sure because we move so fast,
Oh.
right? Like if you is that lightning speed. So you might want the slower pace. You can ask all the questions. Do you know what I mean?
Yeah.
And from 12 by no means slow. From 12 on its own is quick.
Yeah.
Until we think it's faster because it. Yeah.
Yeah. I don't know. I think I would do better. I think
Yeah, I would say probably for you, you would have this class just because. Yeah. Because often what will happen is I'll be like, I'll be like, you want to start with that, so we'll do more.
Oh.
Right? Yeah. Although we could be fine. You know what I mean? Like, it could be fine for you. It just depends on what you want to become the course.
I was wondering because I think
Yeah. Well, you're taking first order APs in semester 1 anyway, I would say no to it. Wonderful.
Yeah.
You know what I mean? Like, yeah. If because you're only one English, why not, right? But you don't want to overload yourself with this. Yeah. Yes. I think because most it's just the regular. Most of it is just the regular. Yeah. Yeah, which is fine.
But if I get all of this, like,
Dude, every single time told me like
It's always
insanely fast. Like,
what are you doing? Okay, so let's do a little lesson there. Yeah, so let's find a piece of paper.
It's not even anything
Yeah.
extra, it's just.
Oh, before that, I'm gonna give everyone their test grades. Okay. Folks, I'm gonna give you your test grade. You can come up here and I will tell you, line up one by one, give each other space. Be like it if you're at the pharmacist. Stand 12 feet back from the first person. Everyone else can line up right behind each other.
try not to disappoint me too much.
Okay, where are we? This is not the right page. Out of 40 by 42.
Out of 44?
Yeah, it's out of 44. 42.
I know I saw.
Alex, 42. Sammy, 43. Out of 44. Amir, 43. Out of 44.
43.
Andy, 39.5. Dylan, 39.5.
I know.
Hussein, 43.
43.
43.
Did you mark
The
that?
way you walk.
I haven't marked it yet, no.
All those pockets.
Hi. What do you think you got, Ryan?
48.
Out of 44?
Out of 44.
Yeah, what do you think you got?
Thank you.
Abbasin, 37.
All right. It's fine.
Anyone else want their grade? Abby, 42. J, 41.
It's out of what? 44?
44.
Okay, thank God.
Super, 43.5. It's a little spelling mistake. 43.5.
Thank you. Good, something. Great.
Yep, for your test. It's out of 44. J, 43.
Wait,
43. Pen. So, where did I put that pen? There it is. Alright, so our rules are here. Okay, and so the first 4 rules we already know. Alright, and now we're going to be working on those ones. So like, let's say we had, for example, C to H2. Alright, so we say I've got 2 times 4
Make that.
plus 2 times 1
This one is hard.
is 8 plus 2 is 10.
Okay.
Now, this structure, hydrogen's always left on the end. Okay, so step 1 is the valence electrons. Step 2 is the skeleton structure. So the carbons have to
Yes, work. Jesus Christ.
okay, because they have to. Hydrogen has to be on the ends, so hydrogen's going to be on the ends. All right, so that's step 2 is the skeleton structure. Step 3, add lone pair, so everybody has an octet. So hydrogen doesn't need an octet, but these guys. So basically make sure everybody has something on the top, side, bottom, whatever. Top, side, side. Okay, and then we say count and check. How many electrons in the structure? 2, 4, 6, 8, 10, 12, 14. Oh dear, that's a mismatch. All right, up till this point we haven't had that. So what we do is we say how many pairs? Too many. How many pairs too many?
What? Ask them.
Yeah.
Yeah.
Okay. What that means is that now in step 5,
I can't go to work.
A, we're going to erase 2 pairs, 2 lone pairs from the central atoms.
Oh, yeah, you're gonna get dumped one day.
Okay. You could do them both from 1, or you can do them 1 each. I'm going to do 1 each just because I like symmetry, but you could do both of them from here. Okay. And this is why this becomes important, because we erase 2 pairs, and now what we're going to end up with, we're going to end up with multiple bonds. So 2 multiple bonds could be, maybe we have a double bond here and a double bond here, that's a multiple bond and a multiple bond. Or it could mean that you have a multiple bond where you have a triple bond, there's your multiple and your multiple. Okay, so for part B, we're going to take a different 2 pairs. Okay, 2 lone pairs and turn them into bonds. Yeah, exactly. So you'll take this one, move it in here. You'll take this one, move it in here. Be like, okay, I got H, C. Yeah? C, H. And now you can count your electrons and see, did we successfully get 10 electrons? 2, 4, 6, 8, 10. We did. All right, and then we can say, does everybody have 8? If we look at this carbon, it has 2, 4, 6, 8. This carbon has 2, 4, 6, 8. And hydrogen's only 1, 2 anyway, so we're good to go. All right, and that's basically how it works. So the lines are bonds. Yes. That's it. That's the whole lesson. We just did a bunch of different examples. Okay? And so if these numbers match up, then you're just done. But if they don't match up, then you go on to step 5. Okay? Yeah. Yeah. So step 5 is when they don't match. So if you say count and check, if they're the same, you're gonna go to step 6, check and see if there's an island. If there's too many, you're gonna go to step 5. Erase lone pairs, turn pairs, and flying pairs. Keep this number the same. If there's 1 pair, you'll erase 1 pair and take 1 pair and turn. Okay. We haven't talked about resonance structures yet. Don't worry about that. And make sure you don't want to, like, let's say we had aluminum chloride, F, and you know we've done everything here. Okay, and it turns out that the number of electrons in here is the same as it was originally. Okay, but aluminum, we would erase a pair from aluminum, but then we'd be like, oh, aluminum only needs 6, so I would not turn that into a double bond. Okay? That's it. Yeah. And the only other thing is that if you had a structure like this, CH3 and H2, just figuring out what the skeleton structure is, just remember hydrogens always have to go on the end so that the carbon would have to be attached to the nitrogen. Because this has 3 H's attached to the C, you would put HH. No. And this would have a 2, so you would just put 2 H's. No, because it's all, this is not an ion. And then here we would fill that in, and it turns out we have, let's see, 4, 3, 5, and 2 electrons, so that's 7 plus 7 is 14 electrons. 2, 4, 6, 8, 10, 12, 14 electrons. It's kind of complicated, but if you look at this, you're like CH3, H3, just everything's a square, right? Because at the top, the bottom, the side, and the side. Yeah.
You always want the
Hydrogen should be at the top and the bottom, the side, and they should always be on the outside. Okay. Yeah. Okay, with your tries, let me know.
You don't utilize
I'll tell it to be loud. A lot of gas.
She said you tried. But you're supposed to No, this isn't complete. This is like.
Thank you for the offer. I saw it online. Debbie's. Oh, she's been getting such right there. Right there. She can
Cause like.
Okay. I'm locked in.
I think it was just a bit more.
I told them, like, I really love it. She was like, oh, yeah, let's try that. Oh, I know.
How many of you get?
So, okay.
Yeah.
Okay. As long as I get it back.
Yeah, I'll be at most of.
Are you? Wait, are you skipping for it? It's fine.
Johnny.
But I might like kick it. So I might. Look, this next one.
I said it. Bro, you dare whatever dares himself. It's all like, oh, so she's fine. For that,
Oh.
And.
I was just saying, people talking about like, you're coming to us now, and then you're be off. Give me a chair, which I was not normally. I'm just having to, you know. She has very good voice. You should have too, you know. And she actually called me. Well, also, about like, imagine they don't think like that long.
Or you can do that.
It's
Here chemicals, or you can make
How it's fun.
Okay. Okay. Yeah, yeah.
Alright, so then you have work. Is it right? Yeah.